My name is Edie Punt. I'm here with my colleague, colleague Jake Gotham. We are both product engineers on the core mapping team in Redlands. We work in the software products division. We work on both ArcMap and ArcGIS Pro, all things related to mapping, specifically working with symbols. So we're going to talk about cartographic representations. They've been part of ArcGIS since version 9.2, and they're a different way of thinking about symbology in ArcMap. So let's begin. A number of you said you were brand new, so what are cartographic representations? They're a different way to symbolize features. We sometimes call them just representations, sometimes cartographic representations. The reason being is they're really sort of optimized towards solving cartographic challenges. So we're really interested in the display of features at a specific scale. A lot of this is meant for mapping for hard copy output, not entirely, but that's really the focus of representations. What's different about representations from other symbols, just the standard symbols in ArcMap, is that they're also a storage model. So with standard symbols in ArcMap, you have data, and within the context of a layer in ArcMap, you apply a symbol, and they're not really connected to each other. With representations, we store symbol information right inside the feature class, so the data knows how to draw itself. And that's a little bit of a different way of thinking than the standard symbolized layer with source data model. So representations really are a part of a feature class, but since we are thinking about the way the features are displayed, we manage them through the layer. And that's a tricky concept because nothing else that we do with the layer really impacts the source data. But it's important to understand that when you're working with representations, you can be actually impacting your source data. And you're going to see us refer back to that a few times throughout the presentation and through some of the demos that Jake gives. So let's look at a couple examples. Representations are a little hard to get your head around conceptually if you're new to them, but sometimes seeing some examples helps. So I've got two little mini maps here. On the left is standard ArcMap symbology, and on the right is representation symbology. And at first they do not look very different, and that's kind of the point. Representations are not supposed to look different. They act different. They have different behaviors. I've highlighted a few things on the right that are different. So take a look at the red circles. You see some more cartographically pleasing dashing. So we use representations to control how dashes get phased. So we can ensure that it bends and joins and corners. We're on the dash part of the dash and not the space part of the dash. So we don't get ambiguous corners. Representations include something called effects, and those are different aspects that you can add to the symbol. We'll see a number of examples of that, but one of them is shown in the blue circles, which is a way to mimic a drop shadow appearance. So we're working on a 2D map. These are not extruded buildings. We're just getting an artistic drop shadow look with an effect here. In the orange ellipse on the lower right, you can see another aspect of representations where we've been able to set the rotation of point symbols. Those buildings are point symbols, and they're getting their rotation from nearby line features. So we've done that with geoprocessing. We have a geoprocessing component to representations. Similarly, in the green circle, you can see the result of our Create Overpass geoprocessing tool. So using representations, we can manage that bridge feature. We've found an intersection, and we've built the masking and the bridge parapets, the sides to the bridges, all from that geoprocessing tool. Here's another example. Representations can produce dynamic geometry, which can differ from the spatial geometry. Now, what that means is the thin line you see for the waterway here, that's the data that's stored in in the line feature class. And it's a little bit too crude for this scale. Using representations and a smooth geometric effect, we can have a different appearance at draw time. So we're drawing a smoother line than we actually have in the data. So we haven't processed this, we're not storing that shape anywhere, it's just happening at draw and display time. Feature classes can have more than one representation. That means, I told you originally, feature classes know how to draw themselves when they have a representation. They can know how to draw themselves in more than one way. So we can have multiple representations on a feature class. So depending on where this data will be drawn, it can know how to draw itself in different ways. Representations can be data-driven. We talk about using the attribution of the feature class to drive the symbology. And this is a little bit different than just the renderers that are available in ArcMap. Here we can drive very small components of the symbol. So this is a very simple example that I have on the screen. You can get into much more detailed, powerful examples of this, but for the purpose of explaining what I mean, I've put together this very simple example. So these 3 road classifications are actually drawn with a single symbol in representations. We're using 2 fields in our table, one for casing and one for fill on the symbol, to create different depictions. So you see in the street case, so at the bottom of the table there, we have a fill of 0, and that's these gray lines. Do I have a cursor? I do. Okay. I guess they look black up there. There's no fill at all. We just have a casing of 1, and we get this appearance. When we have a slightly larger casing and fill, we get this appearance, and an even larger casing and fill, we get that appearance. Like I said, it's a very simple example, but when you start building complex symbols and you have complex data, you can really start to get some powerful effects here. So, how do I get started? This sounds great. What do I do? The easiest way to get started with representations is take a symbolized layer. So you already have a layer in your map, symbolized the way you want it, looks quite nice. Right-click on that layer and choose Convert Symbology to Representation. So what that will do is take all the symbols in your layer and make a representation from it with individual representation rules for each symbol. Now, understand that when you do this, you are actually creating something on the feature class. And what you are also adding to your feature class is 2 new columns. You must have access to change the schema. You need to be able to acquire a schema lock to do this because it is a schema change. You don't want to go through this command every time you want to draw your layer with that representation. We're going to see that in a moment, that once the representation is there, you can get back to it and access it. You don't necessarily need to convert each time. So here is a look at the layer properties dialog. If you have used ArcMap at all, you're probably familiar with the layer properties dialog and the symbology tab. Once a source feature class has at least one representation, you will see an additional heading here, which is the representations. So if I've just used that command, convert symbology to representations, I will see this heading, and the representation I made will be listed here. Chate's going to demo all this. It'll be much clearer when you see it. In this example that I have on the slide, I have 2 representations on this source feature class, and I'm currently drawing the layer with the first representation. I'm not using this one at all. Within this representation, I have a number of rules. Representation rules are synonymous with symbols, so you can just think of them as this is a representation, and I have 5 separate rules or 5 separate symbols associated with it. Sorry, let me go back to that one just a moment. So like I said in the previous slide, you don't need to convert every time you want to get back to that. If I'm working with this layer, I can still go up here and choose single symbol or unique value or any other way to draw that source feature class, or I can come back and access these representations again. They don't go away. They're still there. They're part of your source feature class. So I've talked about representation rules. What are they? Rules are synonymous with symbols. They have a set of drawing instructions. A rule always has at least one symbol layer, but can have more. We think of the symbol layers as these primitives, the building blocks that make up the symbols. If you've started working with ArcGIS Pro, you will see that we took this concept of representation symbology and moved it into Pro for all symbols. ArcGIS Pro uses a new symbol model, and much of it was based on the power of representations. So the things you learn in here are going to be quite applicable to working with ArcGIS Pro symbology. So a rule has at least one, but can have many symbol layers, and it can optionally have geometric effects. And the geometric effects are the components that dynamically change the way the features are drawn at draw time. We're going to see a number of examples of that today. So here is a woodland representation on my source feature class. I have 4 representation rules. This one is highlighted right now, called woodland, and here is all the information, all the properties that go with that rule, and we can see we have 3 symbol layers. We have 2 marker symbol layers and 1 fill symbol layer. Those are the primitives that make up this rule. Here's another example. This lake is a single symbol or a single representation rule. It's made up of 3 primitives. Again, a very simple example, but getting you used to the idea of working with primitives. The 3 layers that make up this representation rule are of type marker, stroke, and fill. And the fill is obviously the blue fill in the water. The stroke layer makes up the outline of the polygon, and then we've placed a marker in the middle. So what I want to do now is flip it over to Chait, and he's actually going to show you how some of this works in the software, and it becomes a little bit more clear that way.
Perfect. Thank you, Edie. So through the demos today, we're going to work with a map of Austin, Texas. For this first demo, we're just going to get a handle on the basics. We're going to create feature representations from existing symbolized data, and we're also going to build a symbol using multiple symbol layers. So for this first part, let's zoom into our road features here. And as you can see, right now we have multiple symbols for our different road classes. So if we open up our layer properties here, we can see that the layer is symbolized now with just a standard unique value renderer using multiple fields. And so we're going to convert this to representation. So this will bring up this dialog. And here you can name your representation. For our purposes, we'll leave the default value. The next 2 entries are the columns that Edie mentioned that will be added to your attribute table. The first one will be the rule ID field, and this is what dictates how your features draw. This next entry is the override field, and we're going to talk about this more later, but basically when we tell our symbols if we want to change the properties, specifically for cartographic purposes, it'll be stored in this field. If we don't want to store it in that field, we can also change the geometry of the actual feature. And Edie will mention that more a bit later, but for now, we'll leave this default value. And we're going to assign the representation rules to all our features. This last checkbox is to determine if you want to apply a new layer or create a new layer with this representation or re-render the existing one. And we have things set up the way we like, so we'll just re-render. So as you can see in the map, very little is actually changed, and that's because our conversion process keeps things fairly close. So as Edie mentioned, when we do the conversion to representation, we get that in the renderer list along with the actual representation that we created. And each of the symbols, each symbol in the unique value renderer is now a rule in a representation. So we have our kind of pinkish roads here, and there's our casing, and then our pink fill. And then now for our green dashed roads, we have 3 stroke layers. This last one has a geometric effect, and we'll go over that a bit more later. But that's basically what creates that the white dashes. So what we want to do now is actually change this fill to match the other road. So we can hit apply. And what happens when we do this is, this isn't what you're typically used to, just changing a symbol property. It's important to keep in mind here that we've actually changed, the rules are part of the feature class representation. And since our representation is actually a property of the feature class, we're actually changing a value that's stored in the geodatabase now. It's not just simply changing the property. So we get a warning when we do this. And once you kind of understand the implications of that, we can just check that box. And so that's our first part. Now we have our road feature, our symbols match. So for the next one, we're going to kind of mimic what we saw earlier in the kayak example. For that, we're going to go to our golf course. So right now, our golf course is symbolized with a simple polygon fill. We're going to add an actual marker to this one. So in order to do this, we can open up our properties. And we can actually see it's already been converted to representation because we have that in the renderer. So in order to add a marker to this symbol, we can click this button, add new marker layer. And it gives us a default black square. And that's obviously not what we want. So we can click on the symbol itself, and that'll open up our selector, where you can choose from existing symbols that you already have, or you can click this properties button. And that's going to open up this marker editor. And it's actually quite a powerful tool. Edie will mention it a bit later. And that's going to allow you to either create a symbol from scratch. There's a variety of tools here to do that. Otherwise, you can actually modify your existing symbols. So today what we're going to do is actually import from a font glyph. So we have a nice golf course symbol here, but for our scale of map, it's a bit too complex, too many things going on. So what we can do is just click on the symbol, right-click, and choose this option here called Explode Multi-Part Geometry. And what this will do is, as you can see, it's going to actually separate the different parts. So what we're going to do is just delete this hand trap. We can change the color to pick something a bit more fitting. Change the size. So we can hit apply and see what happens. It should add so you can see in the map that it's going to add the marker right in the middle. And that's obviously in conflict with our annotation, so we can actually just offset that simply by just changing these values here. So there we have it. Fairly quick steps. You can change properties there, and we have a multi-layer symbol.
Thanks, Jake. Okay, we've talked a little bit about the symbol layer primitives in the rules. I also want to talk about geometric effects. These are the optional parts, but this is where a lot of the power of representation comes in. Geometric effects are the aspects that dynamically change what you're seeing at draw time, and marker placement styles are what determine how markers are placed within the context of symbols. So a little bit of review. Symbol layers, that's what contains the actual drawing instructions. Those are the primitives. The geometric effects are the dynamic geometry changes, and the marker placements are the marker positioning instructions. So that can be as related to point geometry, or perhaps markers along a line, at line ends, at the center of a line, within a polygon, maybe one single point in a polygon, the way we had with the kayak or the golf course, or maybe dispersed throughout the polygon. So that's what the marker placements are. Geometric effects, I've said this a few times now, dynamically change the geometry at draw time. So the geometry gets changed at draw time and then the symbol is applied. What is powerful about geometric effects is we can insert them into the rule, into the symbol, either globally, so they impact all those primitive symbol layers, or on only one of the symbol layers. They're also sequential, so they have a cumulative effect. The output of one dynamic process can be the input of another. We can start building some complex symbology here when we tie all of this stuff together. If you have a little bit of coding experience, you can write your own. It's an extensible system. We have some samples in the .NET SDK, and you can take a look there, some helpers to get you started. But if you have some ideas on how you would like to dynamically change your symbols, it's not that difficult to create your own geometric effects and plug them in. So a word about representation geometry logic. The way I explained this when I taught this session earlier this week is we like to give you a lot of rope to hang yourself with representations. So you can run into a situation where you've built something that is not logical. We don't really stop you from doing that. And the reason is because of what I just said. These representation rules can be applied sequentially. So you might be in an interim state where you're adding effects and you've gotten yourself into a geometry illogical state. The reason that can happen is effects can actually change geometry. So far we've just talked about maybe smoothing a line as an effect, but we can also switch geometry type. And probably the easiest example to get your head around that is thinking about a buffer. We can start with point geometry, add a buffer geometric effect. That's exactly what I have here on the slide in the example. What that's doing is dynamically creating a polygon around each point. I haven't generated true polygons in my feature class or in my geodatabase. I'm just dynamically creating polygons, and those polygons need a fill to fill them. So that's the state I'm in here in this very simple example. I have point geometry. I've given it a buffer, geometric effect. So now dynamically I'm working in a polygon mode, but I have a marker placement that says on point. Well, there's no longer a point to draw because I have polygons. So what I really just want you to take away from this slide is that when you see this, all it means is you're in an inconsistent state, and stop what you're doing and take a look. And the quickest way out of this is, instead of on point, I just need to click this, change my marker placement to within polygon or something like that. So when you see that, it tells you you have a geometry disconnect, and you need to stop and think and look at what you've built and make sure you're still logically in the same type. Some of that's just practice. But I wanted to make mention of that because when people are new working with these, they see a warning symbol and they think, oh my gosh, what have I done wrong? So here's a couple more examples of geometric effects. We've talked about dashes already. This is a way using the geometric effects and the representation control points, which are specialized vertices in the geometry. You can control your dashing. So we have nice, very obvious intersections here with our dashes. This move geometric effect I showed right at the very beginning, we can use this for getting the look and feel of a drop shadow. So it's just a simple transformation effect. I'm not storing two versions of every geometry. We just have that effect on there. The extension effect extends lines in a certain length and direction. We use this a lot for building bridge symbols, because often in a database, bridges are just captured as single lines. So the extension effect adds those little bridge parapets to them. Offset tangent is where we have a bridge feature just captured in our data like this. We can use it to build parallel lines across to get to get that bridge effect. Suppress is really useful. Suppress is being run on this blue shoreline here. We wanted to break the blue without actually breaking the geometry. We didn't do any editing here to remove a piece of that line. The underlying geometry is still connected. We've just used a suppressed geometric effect to say between this vertex and this vertex, do not draw a symbol at all. And that allows our swimming area to be not in conflict with the shoreline. So marker placements are kind of similar to geometric effects. They are parts of the symbol. They only come into play when we have a marker symbol layer primitive. So anytime there's a marker symbol layer in your rule, you end up with a marker placement to go along with it, because we need to know how to place those markers. So I've said this already before, that they can be along lines or polygon outlines within polygons in relation to points. We're going to see some good examples of that. Much like the effects, these are also extensible. We have some helpers in the .NET SDK if you have specific needs for how you want to place those markers and it's not available out of the box, you can write your own. So 3 simple examples down at the bottom. On the first one in red circles, this is how we've built a railroad symbol, and we're placing markers along that railway line. The reason that this is a little bit more powerful than the standard way of building railroad symbols in ArcMap is we have a little bit more control over how those railway ticks are placed along the line. In the middle example, we have 2 separate marker layers. You're going to see this in the demo from Chait. It's kind of neat. We can place markers within the polygon, but it's a little bit washed out in the screen. There is a green fill on the polygon, but what I want you to notice is that the markers can actually go outside of the polygon. So the edge of our geometry is here, but we have the option to place those markers, so we're not cutting them off. And here's another example where we're placing markers aligned to other features. So a simple example to get your head around marker placements. Here's another symbol. This symbol is made up of 4 symbol layers, 1 stroke layer, which is the outline, and 4 separate marker layers. So I haven't used any geometric effects here. I'm just working with marker placements, and in fact, just 1 single simple dot. So markers can have different shapes. Chait showed you an example of an entire golf course symbol. In this case, we're just using 1 plain old dot, but we're using it in different ways. So the first marker layer are the largest dots that are around the outside, pointing to it right here. And the marker placement of that is a long outline, but it's not falling right on top of that solid outline because I also have an offset. So an offset of -3 to pull it in just a little bit. So I'm going on the inner edge. Exactly the same is a separate marker layer where I've just made the dots a little bit smaller and pulled them in a little bit further. Here they're -7, so that's those medium-sized ones here. And then the final marker layer are even smaller dots, but we have a different placement. Here we're using inside polygon and just a regular pattern. So again, just a simple example of how you can use really basic things like dots to get a more comprehensive symbol, just easily building up. And you can hopefully envision how putting all these pieces together, you can get some really unique depictions. So Chait showed you the representation marker editor with the golf course symbol already. This is where you have a lot of control over the actual shape. So we have some basic drawing capabilities in here. Probably one of the best ways to get shapes and start working with them is what Chait showed you, which is importing a glyph from a font on your machine. And then you get the geometry right then and there, and then you can manipulate it, explode it apart the way he did, change the colors. So all of the aspects of representation editing that we'll go through in the final section are available for these representation markers in this marker editor. So it's kind of like a little mini graphics package right inside ArcMap for you to help you build symbols. I'm going to pass it back to Chait, and he's going to show you a little bit more working with these effects and marker placements.
Thanks, Edie. As Edie mentioned, it's the geometric effects and the marker placement styles that are available with representations that really allow you to improve and control the appearance of symbols. So for this demo, we're going to go through some of these effects and some of these marker placements. The first thing I have on the screen here is a trail symbol, and it's symbolized right now with a dashed line. And we have a couple trouble spots. We have one down here where it's a little unclear, or at least that corner isn't that clean, and across the river here where it's unclear how the trail actually curves around. So we're going to improve these by adding some geometric effects. So let's open up the layer properties, and we can pretty easily change this corner down here on the bottom. And what we can do for that is actually control this dash geometric effect that's already been applied to this symbol. And right now it's specified as no constraint. And what we're going to do is change this to a half pattern. And so keep an eye on that corner. And so that gives us a bit more of a clean finish. And we still have to fix the top corner across the river. And for this, we're going to actually add another geometric effect. And to do that, we can click on this plus button, and that's going to open up all the available geometric effects for line inputs. The one that we're interested in is the add controlled points. And what that's going to do is it's going to tell the line to flag any vertex that creates an angle, in this case 120 degrees or sharper, as a representation control point. And so what these control points what they act as are constraints for phase symbols like dashed lines, and it's going to force the dash to be centered on that vertex. And so across the river now we have a clean corner, and it's pretty clear to see how that trail is. So for the next example, we're going to zoom into our buildings. And a common effect that a lot of people do with maps is add a drop shadow to polygon feature classes. So what we're going to do for this is let's open up our layer properties like we did, and we can see that the representations render does exist. So we can choose the rule that's there, and we're going to need to add a symbol layer. So similar to what we did before when we added the golf course symbol, we're going to add in this case we're going to add a fill layer. So we can click this button, and actually I added an extra one. So we're going to move it to the bottom of the order, and we're going to change the color. I want to have a little more of a subtle color, so we're going to choose. And in order to actually have it offset a bit, it's actually a geometric effect. So let's add one for that. And just like we saw with the dash line, in this case it's the polygon. So these are all the effects available for polygons. So the one that we're interested in is the move. So we can hit apply, and that'll give us a nice drop shadow. I'm going to make it a little bit more subtle, so we're going to cut this in half. So there we have it, some quick clicks, and we have drop shadows to all our polygon symbols. The last example that I want to show is how we can build a fairly complex symbol pretty quickly using marker placement. So for this, we'll zoom into our wooded areas. And oh man, the color is awful. Every projector is different, so we're just so you guys can see it. So right now, as you can see, it's a simple polygon fill. And we're going to add a marker to this one. So let's get to the right one here. So add a marker for this. And just like we did before, it's going to open up the selector. We're we're going to choose a glyph similar to what we did last time. So we're going to choose our tree symbol, pick the appropriate color, and we're going to use this symbol again later, so we can actually save this out to our personal style. So we can do that by just hitting the Save As button, as I did. Hit Finish, and that's going to give us some quick access for next time. So we can decrease the size a bit, and we'll hit Apply, and it should add a symbol right in the middle like we had last time, but we want it to be a forest, so we want more than one tree. So we can change the marker placement, and what I did there, sorry, I did it fairly quickly, but I clicked on this arrow here, and the marker placement that we want is the randomly inside polygon. And we have a forest. It's a fairly sparse forest, but we can change it by modifying these properties, the X and Y step. So we can just change it to 6. That'll control the spacing. So we got some more trees. So like I said, we're going to access that tree symbol that I saved to a personal style again. But before we do that, we have to add another marker layer. And we'll click our tree symbol here. But to give it a bit more diversity, we can make the tree a little bit skinnier. We can center it using this function. We can also make it a little bit darker, just to get a bit of diversity. And we're just going to replicate the functions we did before. But as you can imagine, what's going to happen is the symbols are going to draw right on top of each other. And how we can change that is actually manipulate this property called the seed. And this is what generates the random pattern. So there we go, we're almost there. For this map, I want a bit more of a natural looking symbol for my forested areas. So what we can do is manipulate this property called clipping. Right now it's set to clip the markers at the boundary. So we're gonna change it to this property, the whole markers cross boundary. And so we'll do this for both of our marker layers, or both of our types of trees. And so there we have it. Just by manipulating the marker placement styles, we can get a more representative forest symbol.
One thing I think is neat about that example is you could always get rid of that fill layer underneath and then, really have a sort of organic look to where trees are, even though in your database you've got a defined polygon, but in your map you're just seeing a kind of clump sort of organically spaced trees, and I think that makes kind of a neat effect. So let's switch over to what is really the last section we're going to talk about, which is overrides. So overriding representations is one of the other superpowers of reps. Everything that Chait and I have talked to you about so far is just manipulating the rules as they exist, and they're applied to every feature. So the forestry work that Chait just did, that happened to every feature that was being drawn with that rule. When we talk about overrides, we're talking about exceptions to the rule. So this is where we can manipulate how individual features in our feature class might differ from the rule without completely breaking our structure. We don't have to break the whole structure that we've set up with representations to make exceptions to the rule. So we all know in cartography we can specify, okay, all these features look this way, all these features look this way, but there's always the oddball who wants to be different, So we have some cases where certain features are just different and we need to reflect that. This is also what we use when we drive the symbology from the attribution, when we want a different look for every single symbol based on attributes in the data. So, representation overrides are exceptions to the rule. This is a way to customize individual features. Because of that, it is made while editing. Okay, so that's a little bit different. We've not been in an edit session yet in what we've talked about today. Overrides happen in an edit session because we're working with individual features. And remember, we're working in fields that were added to our source feature class. So we're actually making changes to the source feature class, even though we're in a graphical symbol mindset. There are two types of overrides. There are property overrides. So you saw Chait manipulating different properties, how the clipping works, what the step is, what the seed is. Those are all representation properties, and any of those can be overridden. We also have geometry overrides. We call geometry overrides shape overrides. We use the terms interchangeably. They mean the same thing. What geometry overrides do is actually store an alternate version of the geometry. So I told you back at the beginning that geometric effects can create dynamic geometry that's just used at draw time. Geometry overrides are a little bit different. We're actually storing an alternate geometry. Now, if you remember when I said we create a representation, we're adding additional fields to the source feature class. What those fields are, there's two of them. One is the rule ID, and that's simply the field that hooks each feature to which rule is drawing it. The other one comes in empty. It's a blob field. We have the option to use that blob field to store alternate geometry for these geometry overrides. In fact, the property override information also goes in that blob field, but we can use it to store an alternate geometry. That alternate geometry is only understood by this representation. So if you go take that same source feature class and draw it with single symbol renderer or unique value, ignore the representation, that alternate geometry is not considered. It's only considered when you're drawing with the representation. If you think back to when Chait first created a representation in his first demo, he showed in that dialog there was a radio button with options. That is where you choose whether or not you're going to be creating this override, these shape overrides when you make edits to your features, or whether you're going to be editing your initial shape field. We will have examples of this too. So again, very simple example to get your head around an override. Here we have airplane symbols, and Paris shows a larger symbol in a different color. That's just a very basic example of an override. So we still have the same rule. Paris is being drawn with the same rule as all the other cities. It's just we've made it override to the size and the color in this example. So here's back to that that radio button option. This looks a little bit different because here I have an example of creating a representation from first principles. We've shown you how to create representations by converting a symbolized layer. You can also just create a representation upon a feature class. You can do that from the catalog window. You can do it with a geoprocessing tool. When you're creating a new representation from first principles, you'll see this dialog, and it's very similar. But what I've highlighted is that choice about what happens when you edit features with the representation editing tools. Are you changing the geometry that's stored in your shape field, or are you creating alternate geometry? This is a choice that must be made up front. You have to pick one or the other when you create your representation, and you can't go back. You can't change it after the fact. You can create additional representations with different behavior, or you can delete your representations and start over. But once the representation is created, you can't change your mind on this. So that's what that radio button choice is talking about. And again, we will see some examples of that. So there's a few different ways to create these overrides. We have a representation toolbar that gets activated while you're in an edit session, and we can do some of these overrides interactively, and that's kind of nice when we're working with cartography, because we're in a what you see is what you get, a WYSIWYG mode. We see the symbols, we can click on the symbology, not You don't necessarily have to click on the geometry, and you can change the appearance of these symbols interactively. And that's kind of nice. It puts the art back into cartography for us. We can make an override by explicitly changing a rule property as it exists on one feature. So Chait just built the rule of the forest, and he used an X step of 6 on everything. Well, you may select one small feature and say, for this one, I really want an X step of 4. And you would just type 4. And that is also an override. We can use a field in the attribute table and connect that to a property. So instead of saying, I always want X step 6, or in this case, I want X step 4, you can connect it to a field that is full of 4s and 6s and 5s and 9s and drive it that way. That's attribute-driven symbology. And the final way is with geoprocessing. We have some tools in the Cartographic refinement tool set. This is in the cartography toolbox that interact with features that are being drawn with representations and create overrides for special depictions. We're also going to see that in the final demo that Chait has for us. So the representation toolbar has got a lot of great stuff on it. Again, it's only activated when you're in an edit session, so it's another toolbar. You open it the same way you open all the other toolbars. It doesn't really light up until you're editing, though. So over here we have selection tools. If you're used to using Illustrator, some of these might be familiar. The idea of a black select and a white select, that's selecting a whole feature or individual vertices of a feature. We have some tools here to manipulate the vertices. So Chait's talked to you about representation vertices and how they can be used to drive some effects like dashes. And then in this section right here, we have a number of tools. These are the representation property editing tools. They come into play when you click this last button, which opens this dialog, the representation properties dialog. Representation properties dialog has two sides, the tools and the drawing. I've shown you an example of both. So in the drawing side, here is one feature selected and the rule as it exists applied to that feature. You can see right here, there's a little paintbrush that indicates that we have an override. So if you think back to Chait's example of building the forest, here's an override. The rule points to 6 point for next step. In this example, for this specific selected feature, we have an override of 8 point. On this one, this is the tools side. This only gets lit up when you have one of these selected. So you can see right now the tool that we have selected from the toolbar is the resize tool. Once we pick one of these modifying tools, we get a whole list of the symbol and all the properties from all the layers that can be modified with the resize tool. So there's all sorts of stuff you can resize in the way we've built this symbol. This is actually the symbol that Chait just showed. So we have two different marker layers, we have an outline layer. So what do you want to resize? Do you want to resize the width of the outline of that polygon? Do you want to resize the X step? So you can pick and choose what aspect will be resized interactively when you use that tool. Chait's going to show you an example, and it's way cooler to see than to listen to me talk about it. So I'm just going to move on. Here is an example of hooking properties to a field. So we can specify an angle in the rule. We always want these squares to be on a 45-degree angle so they look like diamonds. Or perhaps more powerfully, we can say, actually, I have an angle already for every single feature. I want to use that. So we hook up this property in the rule to a field in our data, and that's where the values come from. So that's considered an override because we're using a different value for every single symbol. And there's a lot of power in that. And this, I've got the point here. What this does is reduces duplication in rules. I don't have to set up a different rule for each angle or something like that. I can get a lot of differentiation from using attributes in my values in my attribution. So I mentioned geoprocessing. Under the cartography toolbox, there are two tool sets you probably want to be familiar with if you're a representation user. The one at the bottom here is the representation management tool set. This is where you do exactly what it says. You manage your representations. So I told you there are different ways to create a representation. You know, the easiest way, the one we started with, was just converting a symbolized layer. I told you can also do it from first principles, from the catalog window. You can also do it here. You can just use a tool to create a representation and tell it which source you're using. Calculating representation rule that applies rules to your selected set. You can get rid of your representations by dropping them. We have a number of management tools in there. We also have the cartographic refinement tool set. This is where the fun cartography happens and where we're processing features, leveraging the power of representations to make some different depictions. And Chait's going to show you a couple of those. We don't have time to go through it, but here's the one I mentioned early on, create overpass. That's where you find overlapping lines and it manages your masking for you. That's a good one to take a look at. Here's two where you can create those representation control points that help drive your dashing. So most of these tools are available at the, I believe, the mid-level license. We used to call them, it's the standard, thank you. I was like basic, advanced, there's one in the middle. So at the standard license level, we used to call them the ARC Editor license. But just like any other geoprocessing tool, you can just go to the help page and see what the licensing level is for it. So let's go back to Chait's last demo where he's going to show you some of the override capabilities. Like I said, they're a lot more fun to see in the wild than look at a slide.
So as we just explained, you can have overrides for both properties and geometries. For this last demo, we're just going to go through a couple examples. The first one is a field override. And right now we're zoomed into our orchard symbols. That's what these are supposed to be. So the markers for these orchards are placed inside the polygon. And this kind of mimics the rows that you would see in an orchard. However, it's not as clean as we'd like. I think we can improve this by actually changing the angle of the grid. That's going to, the angle of the grid will match the angle of the polygon. And to do that, we're going to open up the attribute table. We're going to open up the attribute table this time. And then we'll add a field to this. So we'll just call it SimAngle, set the type to double. And this will add it here. So what we're going to do is leverage some of our geoprocessing tools that we have. And the one that we're going to use is this calculate polygon main angle tool. And we can choose the field that we just created. Just a bit of a note, this last method is optional, but it's set as graphic, which is the default. And that basically means the angle is calculated counterclockwise with 0 at north. And so let's run the tool. And it's going to, so now we have our field, our column is hydrated now. So now that we have that column there, we can open up the layer properties, and to see all the property overrides that are available, we have to actually switch views. So we can click this database can here, display field overrides, and that's going to show us all of the properties that are able to be overridden. So the one that we're interested in is actually, let's choose the right rule first. So there we go. But same thing applies. The one that we're interested in is this grid angle. And we can choose the field that we just created. And if we go back to the view that we've been working with before, we can see that the default value is 0. That's going to stay there, but this icon here, the database can, means that we're actually deriving our values from the attribute table. So kind of a subtle change there, but now our orchard markers are shifted and mimic our polygon angle. So for this next part, we're going to actually zoom in just to this orchard here. We're going to apply something called an individual override. And so here we have mostly what we want. We just have one row that's a little bit out of whack. So to do this, we have to actually start editing. And that's, once we start editing, it's going to activate our representation toolbar. And I'll just dock that. And so we can click the feature that we're interested in, and that'll open up this properties window here, and we can set the X offset that we want that's going to fix this orchard. And I set it 3 because I've done this demo before, but it's really hard to actually know what to do there. So most of the time you're going to change, or you're going to modify these properties or these features interactively, and that's what Edie mentioned before. So to undo this, we can just click this paintbrush. And the tool that we can use actually is this move tool. Right now, it sometimes trips up users, is you switch to this tools and you think that, oh, I have my feature selected, but no tools there. To actually see the tools, you have to click, or to see the options, you have to actually click the tool. So that'll open up this window. And the one that we want to manipulate is this X offset. So once we have our tool selected, which is our move tool, we can just click on the feature itself and make the necessary changes. And we can see here, I actually just switched it the other way, but that'll assign the value here. So the next thing I want to show is actually a shape override. This is something we brought up earlier. So far what we've been doing is property overrides. So for this, we're going to zoom into a different feature. So here in our last example, we have a railroad feature that's in conflict with our roads. So we're going to use one of our tools in our representation toolbar to resolve this. So for now, we're going to choose this lasso direct tool. Actually, first we need to select our feature. Okay, there we go. So we'll select the place where it's in conflict. So once we have this selected, we can choose the appropriate tool, and the one that we're interested in is this warp tool. So we can click on that and I won't do the greatest job here, but at least we'll get it out of conflict. So let's save our changes. And so what we did here is we changed how the feature draws on the map, but we didn't actually change the source geometry. And I'm going to try to prove that to you by making a copy of this feature. And then I'll paste it back into the table of contents and symbolize it with something else, and that'll show you that I haven't actually changed anything. So we'll just symbolize it with something simple here. So we'll clear a selection, but you can see here that our source geometry hasn't changed, and that the only thing that we modified is just for cartographic purposes, so you can use your source geometry for any analysis that you would like to do. That's it.
Super, thank you, Chait. I'm going to put this back up in a moment, but I also want to, I'm sure you've seen this rigmarole. Please do fill out your survey if you're about to head out to somewhere else, but I'll put this back up. We have extensive documentation on representations. We have training and tutorials. There's quite a bit of resources out there. I said it at the beginning, but I can repeat it again since we also have been talking a lot about ArcGIS Pro this week. The power of representation symbols were brought into the unified symbol model in ArcGIS Pro. So in ArcMap, things like effects and marker placements and this idea of building symbols from primitives is only available for representation markers. In ArcGIS Pro, all symbols work that way. They're built with primitives, and you can apply effects. So like I said at the beginning, if you're working with representations, that knowledge is going to carry over for how you work with symbols in ArcGIS Pro. One more note, because I know I'm probably going to get this question. If you have representations in your maps right now and your layers, and you're interested in using ArcGIS Pro, you're probably wondering what happens when you bring them into ArcGIS Pro. So where we're at right now, we just released version 1.1 last week. If you import an MXD that has representations into ArcGIS Pro, you will see those, all your features come in, they will look the same. The representations cannot be modified in ArcGIS Pro at this time. So this editing and modifying that we've been showing you here, you cannot yet do that in ArcGIS Pro. But you can bring those representations in and view them and draw them. We are working towards that, but that's not available yet. One kind of helpful workaround that I'm going to offer you, if you have done a lot of work in representations and you're thinking about going to ArcGIS Pro, is when you are working with your layer properties dialog in ArcMap, the one that we've shown over and over again with the rules and the properties, down at the bottom there's an option to save out each individual rule into a style. You may want to consider doing that. If you save those rules, if you put a lot of work in any of your representation rules, save them into a style. Styles are a little bit different in ArcGIS Pro. They're no longer .style files, they're .stylex files. They're a different database behind the scenes. They're now a SQLite database. But if you save your rules to a style, you can import styles into ArcGIS Pro, and what that will do for you is take all those nice representation rules you built and convert them to ArcGIS Pro symbols, and then you can use those symbols. So that's a little bit of a backdoor for you that is quite nice. And if that didn't make sense to anyone, please come up and talk to me after. But that is a good way to get started if you've put a lot of effort into your representation rules already and you want to start playing with them in ArcGIS Pro. So we do have a few minutes for questions if anyone has anything to ask. If you're leaving, thank you so much for coming. I appreciate the time you gave us. Any questions? Does that mean we were so thorough? Thank you.